So, every time we say strength, stress, ductility, already I have explained these things in previous some lectures, but again just to recap, I have drawn one figure like stress and versus strain. Okay, and let's say I have taken on mild steel. Okay, now pull it from top to bottom. Okay, let's say mild steel or ductile material. Ductile material means you if it pull it, it will not break suddenly, rather it will create a very thin long section, then after that it will break. This is called ductile material. Okay. So, if I pull it, it will be getting elongated. So, that part is called proportionality limit. Proportionality limit will be coming here. So, let us say you take one elastic band, you enlarge a little bit, again leave it, again it will come back to its original position. So, that is called elastic limit. Within that there is no deformation, plastic deformation not happening. Plastic deformation means you enlarge it, you leave it, it will not come back to the original position. Okay. So, it is called plastic deformation. So, okay. So, if you design one pressure vessel and it is getting plastically deformed, that means after high pressure, if you release pressure, again it will not come back to its original position. That means material is getting deforming permanently. When permanent deformation is there, it can be more dangerous. Okay. So, plastic deformation is permanent deformation. Okay. But elastic deformation means it will be coming back to its original position. So, normally our whatever material or whatever thing you design, you have to work within that your proportional limit. If you are going towards ultimate strength or fracture side, then your system will not sustain, it will break. Okay. So, if you give some more pressure, more tensile stress, like initially you worked up to proportional limit, then you enlarge more. So, then yielding will be starting. Yielding study means permanent deformation will start. Okay. Then you enlarge further, ultimate strength will be coming. Then if you enlarge further, it will be it will give fracture. Okay. So, whenever you are designing anything, it will be within your proportionality limit. So, material property, maximum amount of tensile strength, pulling or stretching, strength, that is called tensile strength. Okay. So, material maximum amount of tensile strength you are applying. So, if you apply more than that, then it will be permanent deformation. Okay. So, material will stand without breaking or undergoing deformation. Okay. So, that is called tensile strength. If it is deforming, then plastic deformation happening, then your system may not work. So, your system must be within this range. Okay. And whenever we are talking about stress, strain or stress or pressure, so in that case unit will be Pascal, megapascal, psi, Newton per meter square. Okay. So, you have to sometime you have to use conversion factor also, but units are Pascal, kilopascal, megapascal, kilopascal also possible, only Pascal, gigapascal also possible in certain situation, psi, Newton or kilonewton per meter square, those are unit for pressure or stress. Design formula. So, whenever you are designing a pressure vessel, so what will be the water thickness, wall thickness? So, this formula will tell, okay, this much of wall thickness you have to use. So, if your maximum allowable working pressure P, maximum allowable working pressure PSIG in unit, and R is inside radius of the system. So, S is maximum allowable pressure, allowable stress. Okay. E is your joint efficiency. Okay. Then wall thickness will be for cylindrical cell. So, here so actually I have to tell something else. Okay. Whenever you are designing a pressure vessel, it will have different heads. Okay. Heads means like you have pressure vessel, and previously in all separate design actually we had drawn figure like this, right. Now, actually every time you may not have that much of figure. Sometime it may have only shell like this rectangular vessel, sometime it will be hemispherical end will be hemispherical, this head, Okay, sometime it will be having parabolic, okay, not parabolic, ellipsoidal head, 2:1 ellipsoidal head. Sometime conical section will be there, okay, and sometime there will be internal cone, okay. External cone will be like looking like this, okay. Internal cone is like this, it is completely like this, and you are creating cone inside. So outside one metal will be there, inside also there will be metal. So inside will be collecting your sand and other particle, outside will be a normal pressure vessel, okay. So cone bottom vessel used for solids, if solids are problem, and maximum cone angle 90°, okay, 90° cone angle possible apex. So alpha is 45°, normally it will be there, and if you are using 45° or 60° cone angle, then it will be referred as alpha 60° cone or 45° cone, like this. Well, vertical vessel normally it will have standard ellipsoidal head. Ellipsoidal head contains pressure. The cone can be the steel made. Okay, this is steel made and it will be thin sheet also, thin, okay, because outside also it is holding pressure. This is just guiding the sand. Now we'll go to this design formula. If you have wall thickness, if you have 2:1 ellipsoidal head, then wall thickness formula is like this: T equals PD. T, this is T. T equals PD 2AC 0.2 P, and wall thickness for hemispherical head T equals PR 2AC 0.2 P. This is PD, this is PR. Wall thickness cone T equals PD 2 cos alpha AC 0.6 P. Okay, this using this formula later we will solve some problem. And your thickness, now from thickness we have to calculate our shell weight, because weight is one important factor for design and use. Okay, so shell weight W equals 11 DTL. W equals 11 DTL. What is D? D is ID of shell. Okay, so this is ID, and T is the wall thickness. Normally this shell will be thin walled shell. Thin walled means D by T will be 20, the ratio, because our diameter is higher and thickness is lower. So the D by T will be normally more than 20. Okay, weight of 1 2:1 ellipsoidal head. So if I have one ellipsoidal head, so weight of that one W equals 0.34 T D square plus 1.9 T D. And weight of cone, if I have cone, then W equals 0.23 T D square sine alpha. If I have skirt length, L equals 0.25 D by 12 plus 2. If you have conical head, then length will be like 0.5 D 12 tan alpha plus 2. Now, what is skirt? I will explain later. Okay, so maximum allowable working pressure you can get from this table. So if you have less than operating pressure, then minimum differential between operating pressure and MAWP or allowable working pressure is 10 psi. So similarly, if you are changing pressure, so your this difference also changing. So maximum allowable stress, this table shows like you have carbon steel, this one, plates and shells, carbon steel. So for that you have different grade 55, grade 60, grade 65, grade 70, and grade A, B, C, different grades are there. For that, for different temperature range, 20° Fahrenheit to 650° Fahrenheit, you have from ASME section 8, you have allowable stress 13,800, 15,000. Okay, so in mathematical problem, if I do not give you the value for allowable stress, so you can get the allowable stress from the table ASME section 8, that from that table. Actually, this table I have taken from book Arnold and Morris. Surface production operation. This one also from Arnold Morris, surface production operation. Okay. Estimating vessel weight. Most cost estimating process starts with W. W means vessel weight. Okay. Both empty and full with water may be needed to design foundation, lifting, erecting, construction. So, when lifting, erecting, because big separator system or big vessels, transportation, erection also one issue. Okay. You fix it, then again you have to fix all the heads, pipes and nozzles. So, that will be big challenge. So, you have to reduce weight as much as possible. So, weight formula is that weight of shell means this one shell, okay, then head, this one head and this one head. Internals may be wave breaker and other things will be there. Nozzle may be there somewhere, nozzle may be entry exit, pedestal, or this one skirt actually where it is getting fixed. Okay, bottom part, it should not be touching on the bottom, rather it will be hosted by some metal structure, this is called skirt, or pedestal like this. Okay. So, when you are calculating pressure vessel weight, you have to include all the parts. Now, problem using those formula, already have seen some formula. So, using that formula, we will try to calculate pressure vessel weight. A free water knockout is fabricated with butt weld and built as per division 1 of the ASME pressure vessel code. Okay. The bottom of the vessel has conical head, bottom of the vessel is bottom of the vessel, that means this is conical head. Okay. So, design pressure is giving 125, maximum operating temperature is given 200 degree Fahrenheit, corrosion allowance given 1/4 inch, material is given SA516. So, if some value is required, then we have to go back to table. Diameter is given 120 feet, seam to seam length is given 12 feet, cone apex angle is 60 degrees, so alpha equals 30, joint efficiency E equals 0.85, and maximum allowable stress 17500. So, here already 17500 is given, so you do not have to go back to your table actually. So, material may not be required then. Skirt plate thickness, skirt plate means this bottom skirt is here. So, this plate thickness is given 0.5 inch. Okay. Determine weight of the vessel. Okay. Weight of the vessel means you have to add all the part. Okay. Whatever information given, based on that you have to add all the part. Compare this weight to that of vessel without the conical section and that to a vessel with 1/4 inch plate internal cone. Okay. So, let us try to solve this problem. So, first start with shell. Okay. Shell formula you can remember, T equals P R S E minus 0.6 P. Okay. So, S value is given 17500, E value given 0.8. So, this gives 125 into P 125, R is D is 60, D is 120. So, R is 60 and SES 17,500, E 0.85 minus 0.6 into P value. P value is given 125. Okay. So, this value is giving 0.05, 0.507 inch. Okay. But you have to give allowance for corrosion. Okay. Corrosion allowance, I think it is given, corrosion allowance 1/4 inch given. So, 0.25 you have to add. So, TC given 0.525 inch. So, thickness total thickness equals 0.25 plus 0.507. So, it is coming 757. Okay, inch. Now, weight of this shell, weight is equals 11 DTL equals 11 into D 120 already given, T 0.757 into 12 equals 8027 into 0.027 lb or pound. Now you have calculated shell, now calculate head. So you want to calculate head, then again T formula you have to use, equals PD 2SE minus 0.2 P. Okay, so that will be giving 125 D 120 2 into S value 17500 into E value 0.85 minus 0.2 into 125. So this is giving 0.505, and so T total 0.505 plus 0.25 because corrosion allowance, so it is coming 0.755 inch. Now weight equals 0.34 0.34 weight equals 0.34 T d square plus 1.9 T d. So this will be giving 0.34 into 0.757 into 120 equals 3866.702 pound. Now we'll go to next slide because slide is filling up. Okay, now cone. So cone will be giving T equals PD 2 cos alpha SE minus 0.6 P. Okay, so the value if I put, it will be coming like this: 125 into 120 divided by 2 cos 30, then 17500 0.85 minus 0.6 into 125. So this will be giving 0.585 inch. Now thickness T total equals 0.585 plus 0.25 equals 0.835 inch. Okay, so weight of the system cone is 0.23 into T d square by sin alpha as per formula. So this will be 0.23 into 835 T into D 120 square divided by sin 30. So it is giving 5532.49 pound. Now skirt. Okay, skirt conical head. Okay, so L equals 0.5 D by 12 tan alpha plus 2. Okay, so this value will be like this: 0.5 into 120 divided by 12 into tan 30 degree plus 2. This is coming, okay, H equals height, okay, because this is like this, so you have to calculate height also. So A, B, C, this is alpha, so AB equals height, this is actually 60, this AB. Okay, so this value will be coming 10.66 feet. Okay, now H, now W equals it is coming LDT into 11 equals 11 into L 120 into 0.5 into 10.66 is giving 70.735.77 pound. So total weight, so shell, head, because it will have shell, then head, then cone, then skirt. Okay, this is shell, this is head, this is cone, then skirt. All weight we have to add. Head, then cone, skirt. Shell weight is 11987.03. Head weight is 3866.70. Cone weight is 5532.05, and skirt weight is 7035.77. So total weight coming, total of the system, total whole pressure vessel weight is 28421.55 lb. Now case 2. That was case 1. So case 2, skirt is changing. So skirt length equals 0.25 d by 12 plus 2 is coming 0.25 into 120 by 12 plus 2. So it is coming 4.50 feet. Now weight is coming 11 into 120 into 0.5 into 4.5. So 2970 pound. So now summary. Summary is coming like this: shell, head, two heads are there. So skirt. Okay. So shell weight is 11987.03. Head weight is 3866.70. So same head, 3866.70, and skirt weight 2970. We got just, okay, altogether it's coming 22690.43 total weight pound. Okay. Now another case is there. Okay, case 3 shows like internal cone. Internal cone weight is 0.23 t d square by sin alpha equals 0.23 into 0.25 into 120 divided by sin 30 degree. Okay, so this will give 1656 pound. Now shell, this internal cone shell, height of the cone, height of the cone equals 10 by 2 radius divided by 10 30. Okay, so it is like this: A, B, C. This is 5 actually, 10. This is 5, and this is 30 degree. So BC by AB equals 10 30. Okay, so AC equals BC by AC, not AB. BC by AC. So AC is 5 by 10 30. Okay. And now from there we get height so height equals 10 by 2 by 10 30 equals 8.7 feet. Okay. Now we go to next slide. So length of the shell, length of the shell, length of the shell is 12 already given plus 20. So how it is like this? So first it is there and your skirt is coming here. Okay. So 12 is there and 8.7 your cone height. Okay. Cone height is there and previously it was 12 and this is cone 8.7, this is 12. Okay, so it is coming 20.7 feet. Now weight of shell W is equals 11 D T L. So 11 into 120 square into 0.757 actually. We got it from previous slide. We got 0.757 into length 20.7. So it is coming 2 so this value is coming 20637.9. Okay, now summary. Shell height, shell weight, weight, then head, skirt, cone. So shell weight is 20637.9 and head weight 3866.7, 3866.7 and skirt weight is 2970.0 and 1656.0. So altogether it is coming 32997.3. Okay. So you can see the difference. If we change design, the weight is changing. Thank you very much for this lecture.